Okay, number 4, I'm looking in my equation, x plus 4. When I'm dealing with x, I'm doing the opposite. So instead of going to the right 4, I'm going to the left 4. Then the plus 5, so I'm going up 5. So my vertex is at -4, 5. And that's also my max or min. So my domain is all real numbers. And to see if it's a max or a min, and my range, and increasing and decreasing, all of that, I have to continue graphing my function. But the symmetry comes from my x value of my vertex. So on either side of my vertex, the function's symmetric. So doing the same thing. So I'm looking at the negative, that's my slope, -1. So from my vertex, I'm going down 1 over 1, down 1 over 1, forever. Okay, so it turns out that's my max. So the very, very top, it's a max. So if it's a max, all my y's are less than or equal to, because that 5 is a point on my graph, on my function. It's part of my function. So now it's increasing on the left. And then on the right, it's decreasing. So it's starting out way over here at -infinity up until -4. And then it's decreasing after that. So -4 to positive infinity, it's decreasing. Number 5, I need to find an equation. It says stretch by a factor. When I see factor, I need to think multiply. So it's stretched, so I multiplied by a whole number. So I have y equals 2 times the absolute value of x. And then it tells me I went right 4. So if I went to the right, I'm subtracting from x. That's all that's happening. That's my equation. So I can graph this to make sure that I did stretch and that I went to the right 4. On number 6, it says I have a domain of all real numbers. That's not special. Every single absolute value function has a domain of all real numbers. So the only important thing on number 6 is that it has a range of -3 to positive infinity. So that's the same thing as saying y is greater than or equal to -3. So if it's greater than, -3 is part of my minimum. And it doesn't say I went left or right, I didn't stretch, so it's just absolute value of x. And then to make it go down 3, I subtract 3. So 7 and 8, I'm looking at my transformations. That's on page 6 in the notebook. And we did the 8 graphs, and we labeled what one transformation looked like at a time. So we have 7 transformations, including the parent function, so that's 8. So 0.75, that's less than 1. So I'm multiplying by a number less than 1. It's in between 0 and 1, so it's positive and it's less than 1. I'm compressing my graph. It's shrinking. So it's a vertical compression by 0.75. And then x minus 7 is going to the right 7. And then plus 4 is going to up 4. And number 8, I have a negative. So that's telling me that I reflected over the x-axis. My y's were positive, now I'm making my y's negative. So it's a reflection across the x-axis. And then I multiply by the 3. So even though negative 3 is less than 0, I have to split it up and say negative and then 3. Compared to number 7, where I had just a fraction or a decimal, that's a whole number. So I take that separately. So multiplying by 3, so that's a vertical stretch by 3. Then plus 1, so I went to the left 1. And then minus 9, it went down 9. So again, you can check this in the calculator. You just put the equation in y1, graph it, and see what happens. Okay, number 9, I need to solve the absolute value equation. So my absolute value is already by itself. It's isolated on the left side. So from there on, it's equal to a positive, so that's good. So I'm going to take the inside, x minus 4, and set it equal to positive 12, and set it equal to negative 12. So I have 2 equations to solve, so I'm going to have 2 answers. So the good thing is I'm doing the same operation to both of these equations. I have to add 4 to both sides to get x by itself. 12 plus 4, 16. Negative 12 plus 4, negative 8. So number 10 is not, like the absolute value is not isolated. I have multiplication, I'm adding on that side, so I need to get rid of all that. I need to move everything over to the right side. So I'm going to start by subtracting negative 4.4. And then the negative 0.3 and the absolute value are being multiplied together. So to undo that, I'm going to divide both sides by negative 0.3. So you could put that in the calculator, 12 divided by 0.3, or negative 0.3, you get negative 40. So I need to stop and think about this. The absolute value equals a negative. The absolute value gives you the distance a number is from 0. Distance is not negative, so if you get the absolute value is equal to a negative, there's no solution. There's no x value you could possibly put in here to make this equation equal a negative number. So there's no solution. So number 11, again, this one's not isolated, so I'm going to make it isolated. I have to subtract 12.5 from both sides, and I'm left with 4 times the absolute value of x minus 2.5 is equal to 0. So then 4 and the absolute value are being multiplied together, so I'm going to divide by 4. And I get x minus 2.5 is equal to 0. So I don't have a positive and negative 0. So when I take the absolute value bars off, I only have one equation. X minus 2.5 is equal to 0. So to get x, I'm going to add 2.5 to both sides. So x is equal to 2.5. So I only have one solution for number 12, or number 11. Number 12, my absolute value is isolated. So when I go and take my absolute value bars off, I have to consider positive 16 and negative 16. So I'm going to start off by adding 4 to both sides. I get 5x is equal to 20, and 5x equals negative 12. So divide by 5. I get x equals 4. And x equals negative 12 divided by 5. On the test, you're going to see decimals. You probably won't see a fraction. But that's negative 2.4. If you want to leave it as a fraction, or if you want to leave it as a decimal, that's fine.